I'm Dr. Jay Anders, and this is Tell Me Where It Hurts, where we discuss some of the big challenges in health IT and how we can solve them so clinicians can do what they do best, care for patients. I'd like to welcome everyone to another episode of Tell Me Where It Hurts. Today's topic and guest have been on the podcast before, but the topic has become kind of superheated over the last several months. And it's interesting, we're going to be talking about OpenAI and generative AI and how it relates to healthcare, the good, the bad, the ugly, and the crazy. So in my research, as part of my position, I've been reading a lot about OpenAI and all these other generative, large language models about what they can do and what they can't do. And I found a couple of things out. In testing it in my particular line of work, I found that it's pretty good if you want to write a letter to an insurance company about a certain denial, or you want to give them a synopsis of a particular medical record or a particular disease. It's not too bad at that. But what's interesting about it is when you start asking it some very detailed questions, either medical or medical coding or anything like that, it has a propensity, if it doesn't know the answer, to make something up. And I found that a couple of times now, which is something absolutely unrelated to what I was asking it, which is a little disturbing when it comes to a clinician and thinking about how they can use this in the future, because the answer that it did give, if you didn't know any better, was pretty good, very convincing, but wrong. So it'll be interesting to see where this all transpires and goes over the next, years, because I think that's going to take a while for it to actually to get there. But today's guest is an expert in healthcare IT, in natural language processing, and basically artificial intelligence as it pertains to that. So I'd like to welcome Dr. Tim O'Connell, who's a practicing radiologist, and he's the founder of Intelligent. And he and his Intelligent team have been working one of the world's first deep learned medical natural language processing engines. They can take text and convert it into usable data and information. He's also the vice chair of clinical informatics of the Department of Radiology at the University of British Columbia, which is a beautiful campus. I've seen it. And he also holds a master's degree in engineering and a bachelor of science in neuroscience. I'd like to welcome back Dr. Tim O'Connell to the podcast.
Thank you, Jay. It's a pleasure to be here. Great to see you again.
Tim and I have had several conversations over the last, I would say, couple of years now regarding some of the issues. But recently, as I just mentioned, OpenAI has opened up what I would call a semi-can of worms when it comes to what generative AI is, how it's used, what it could be, and how it's learned. And I was thinking about this, and the thing that came to mind is it's kind of like a third-year medical student with a photographic memory who has learned every medical textbook it can get its hands on, consumed all this other information that it can get its hands on, but never seen a patient. It can't put it together.
Interesting, very interesting analogy. Yeah, and it suffers terribly from the unknown problem, right? That's what
Yes.
differentiates a third-year medical student from a 10-year veteran, of clinical practice is what you don't know. And that's honestly where, and can be very convincing about what it doesn't know.
Absolutely.
Yeah.
So at Intelligent, you guys are focusing on unlocking data, good clinical data from free text notes and natural language processing to help facilitate that conversion to usable data downstream so we can do all the wonderful things we can do with it. But we've had, like I said, clouding of the landscape with ChatGPT, Bard, you name it. It's out there, and there's got to be at least 20 of them now that I have been looking at. So it's kind of interesting. So tell me how your approach at Intelligent is different than what I'm seeing in all these other models.
For sure, Jay. So I think, this is potentially a very long conversation, but I'll try and keep it short, focus on the bullet points. I think let's go over the similarities first. The underlying technologies are the same, right? We use large language models, we use transformers, we use human annotation, we use, deep learning, AI, all this kind of stuff. We're using the exact same thing. Those companies have really built general purpose things to just have a human interface with text or language or images or the web or something like that. And we've built a medical information extraction system. So, I think number one of the big differences is we've trained our models specifically on clinical data, right? It's been human annotated by physicians specifically for high precision, right? If it tells you something, very high reliability that it's right. Right. Whereas the large language model vendors and generative AI vendors have done unsupervised training of their models on the web and Twitter and GitHub. Right. And so there's just we all know that medical English is not general purpose English. So there's all kinds of specialized terminology and slang and abbreviations and stuff that we've seen that just don't exist in Twitter. Number two, I think really security is really paramount as well, right? And when you're using all these things, you're sending data off into the cloud, right? To someone who actually has terms of use that may say, oh, we can use this data. And if you send it PHI, you're potentially committing a HIPAA violation. And so, our software can run entirely within an organization's IT infrastructure, it can just run on one server or a cluster of servers. So data never has to leave that organization. And really number three are we really use a once through processing technique. You process a document once or a snippet of text once, and then you can ask our system sort of anything you want about it. Whereas these other systems, you might have to, every time you want a different question, it's got to reprocess the text, and that means time and money and delay and all this sort of stuff, right? And we're also deterministic. In other words, if you process one document, you'll get the same answer back both times. Whereas with these generative AI models, there can be quite a bit of non-determinism. In other words, you may get a different answer every time.
Now, tangential to that, using the PHI comes to mind. I've noticed in the literature and some reporting that there are people searching or getting lawsuits for copyright violations when some of these open platforms have used copyrighted material to train their model.
Yeah.
So what's your comment on that?
Absolutely crazy. I mean, I think for these companies to be using copyrighted data, at least in the present legal framework, right? Until, the social contract and governments agree that we can use copyrighted data for other, for this use case. I think the law is pretty clear on that. That's not okay. Right. And, there's certainly concerns about patient consent and use of patient data and this sort of stuff. And there's very likely patient data floating around out there on the web that people have not consented to being released publicly. And if these companies are using it for training, that's not okay.
Interestingly, when I've been doing a lot of testing with some of these platforms, I have never used a real patient. I have always created some fake
Absolutely
dictated note from somebody that I remember back in my practice days where I could, make something that's very convincing and use it for testing. So keep that PHI out of it. And people are exploring that now, which gives me a little bit concerned, like it does you.
Yep. Yeah. And yeah, we only use, for anything that's, trial or demo or something like that. Synthetic data is the way to go. You and I are document generation engines, right?
Yep.
It's easy for us just to create something based on some amalgam of patients that doesn't exist.
Yeah, I calculated one time, I think I've created 100,000 notes in my lifetime, my practice lifetime. It's just a massive amount of stuff. So let's switch a little bit to a use case. Right now, there's a lot of buzz out there. There are companies creating natural language processing, hang a microphone in the room, and you pick up all this stuff, and then you're creating something out of that. And out of that something you've created, you're going to try to create a clinical set of notes / data. And I put data in quotes. But they've also, these large medical systems are thinking how they can clinically augment a doctor's thinking process with some of these things, which gives me a little bit of a pause. So I talked a little bit about hallucinations. Can you elaborate a little bit on that and what your experience has been with that?
Yeah, for sure. So hallucinations are something that these generative AI models suffer from. And I haven't seen anything in the literature yet about a solution for this. And it's a very serious problem. For example, I was having a conversation with someone at one of the large pharma companies, and we were talking about this, and it was a novel and interesting application. And so I asked one of the generative AI models, I said, hey, does this drug cause headaches as a side effect? And it said, oh yeah, absolutely, it causes headaches. And I said, okay, well, can you tell me why you said that? And it said, oh, I actually don't know that it causes headaches. I'm sorry. And so, these models are unexplainable in a large way. So a large amount of work is being done into explainability. Like, why did you say that? Where did you get that? What is your reference? Where did that come from? And so that's a big difference between what we do and the generative AI approach is we are completely explainable and completely deterministic. If we say, oh, the patient had appendicitis, we'll give you the sentence it came from and the character offsets it came from, and was it negated? Was there uncertainty? All this sort of stuff, right? And so these hallucinations are really just where these models are making stuff up, and doesn't seem to be a good way to stop them right now.
So right now, given what we just talked about, tell me where you think these systems actually fit in present, and where you think they might fit in the future.
Sure. I think we're going to see. I think the right thing about generative AI is it can make it very easy for humans to interface with machines, right? And I think that's something we all have struggled with. Like, if I now have a big chunk of my brain dedicated to using speech recognition software, right, which I use as a radiologist in dictating reports. And I have to speak in a certain way, and I know I have to avoid danger phrases that I know will get wrong, and all this kind of stuff. So I think some of these generative AI models can be used to improve this human machine interaction, right? And I think it can be used. We're looking at seeing how we can use generative AI models to make it easier for our customers to get data out of our system once it's already been extracted with high reliability, right? Like, rather than having a human write a SQL query to get at a database, you could use a generative AI model to do a text to SQL, right? Show me all the patients who had appendicitis last month. Boom, that creates SQL, queries a database, pulls out the information, right? There's all kinds of use cases like this. Let alone, we could spend literally all day spitballing about all the clinical use cases of how we could make your day shorter, my day shorter, us doing less repetitive and tedious work about it, right?
We actually, in our work at Medicomp, we have a knowledge-based team, obviously, that works on our index, has created the thing that we use as our clinical engine. And we have started using it for queries like that, but it's always been vetted by the expert before we ever put it in anywhere. So I think that your approach, my approach, other people's approach, when we talk about clinical applications, we have to really be careful to have that last human step to make sure that what you're getting is what you should be getting, as opposed to out there. And it scares me to death when I had patients that would bring in 4 or 5 type pages worth of questions and stuff they got off the internet and everything else. And now they're asking that same question of ChatGPT or Bard or somebody else. And now they're coming in, well, this is what they told me I have, and this is what I should do about it. And I'm thinking, that's going to be a very interesting interaction going forward.
That is, Jay, the old adage of trust but check is key here. And I think if you're showing information to a human that a generative AI model has extracted from the chart, you need to have side by side, okay, human, if you're going to make a clinical decision based on this thing that the AI model said, you need to be able to back it up. Right.
So let's talk a little bit about that training, because one of the things that obviously needs to happen, I think, when it comes to this type of technology, is it needs to be well trained, but it needs to be well trained on appropriate data, not, like you mentioned before, every conceivable thing you can glean off of. what do you think the best approach to that is? We've been working together for a long time, having your NLP model and intelligent focused at our particular sets of vocabularies here at Medicomp.
Mhm.
How do you see that going forward, or how do you think that's going to help refine this whole
Yeah.
aspect of clinical medicine?
Yeah, and I mean, in the the NLP literature is a very broad base of scientific literature and research, no different than internal medicine for you or radiology for me or whatever, right? So there's lots of work that's been done, and it's a well-known framework that you can use a large language model to deal with language tasks and NLP, and this is what we do. And then it has to be fine-tuned. There's this fine-tuning process that happens afterwards. I kind of wish we had a better name for it, but this fine-tuning is a semi-automated step, but it has to be done with human annotated data, right? And so that's where this idea of we're going to take a large language model that's been trained on clinical documents, clinical notes, and there's lots of these LLMs which are available, but then having to fine tune them on human annotated data is the next step, and then you get the output. And so that fine tuning step is an essential step, and not all fine tunes are created equal, right? And so that's where I think the ability we have to fine tune things using medicine as an ontology and medicine annotated data and things like that to be able to extract information from clinical notes with high reliability using your language framework is a real win for our users.
It's interesting that the pressure on all the health systems that they have today with things like CQMs and HCCs, and now there's the Medicare starting to ramp up audits of notes in the whole Medicare Advantage program. Where do you see what you do, what we do, what AI could do when it comes to that particular aspect? Because that's something that I, almost to a person that I've ever talked to that's a clinician, says, I don't deal with that. I just want that to happen. So don't bug me with HCCs and CQMs and all the other alphabet soup that they've now applied to us as clinicians that we have to comply with. So tell me a little bit your thoughts on that.
Yeah. First off, I couldn't agree more. I couldn't agree more. I mean, physicians have an obligation to their patients to create high quality clinical records. And that should never go away. But the auditing function is not a role for the physician to do. And humans will always make mistakes, right? And we're the original wetware, right? So where we're going to be able to use these technologies and where we can use them today is to replace some of this human effort and to speed up this human effort, right? I think if you're going to come down hard on someone and say, no, we're not paying this bill, or this is fraud, or something like this, ultimately this has to go to a human for review. And the question is how can we make that process more efficient and better so that we don't have a human reviewer going, I reviewed 100 cases today and 99 of them were useless, right? Or, right? So it's about getting to that thin edge of the wedge and providing high quality data to the human reviewer who's going to adjudicate something with appropriate peer review and all this sort of thing to make sure that we continue to use these audits and codes for appropriate reimbursement and appropriate quality of care oversight, right? These are very essential and important functions that I think a lot of people aren't familiar with.
One of the things that I have thought about, I've read about, talked to other people about is using the generative AI or an open AI type model for research when it comes to clinical entities, diseases, certain things like that. One of the things we're doing at Medicomp is we're using it to actually have it gather information for us that we can review. Do you have any thoughts on how that aspect of all these open AI type systems will help with clinical research? Because it does have the capability of going through a tremendous amount of information in a short time frame.
Yeah. Well, that's been something we've been able to do since day one of our company, Jay. And so I don't think that's adding on a new capability. So for example, as you know, a lot of research we do is based on chart review, right? You've got a human and you go, okay, look, we did a keyword search and we found all the patients with gallstones. Here you go, researcher, you go through them, right? And so what we can do with really high quality bulk information extraction, which we do with IntelliPro and with medicine, is once you can just process as many documents as you want. You got 20 million discharge summaries, great. Let's process them all, store it all in a database, and then you can start swimming around in the data, right? You can be like, I want to find all the patients who had, hip replacement surgery, and then within 1 month had a blood clot in their legs, and then within 1 week had a pulmonary embolism. And that query takes about 10 seconds to perform on a massive database, right? And how many weeks or months would it take to assemble that cohort of patients and chart review? It's crazy. So I don't think that OpenAI is going to change or I shouldn't call it OpenAI. I don't think that generative AI and some of these chat models are going to change that. They may make the user interface somewhat easier to use to assemble very complex queries, but we can do this today.
I just think that the problem with that particular aspect, when we talk about using these large language models and generative AI, is the fact that they're not being used very much to help with the query, because that's the other thing I've noticed when I've been doing my research on this, is that it's very good about refining a query. It's sometimes not too good about getting the query. So
right. Yeah,
it's an interesting dichotomy of what it can do.
Absolutely. And there's so much gold in these records, Jay, right? Like, the old days of medicine where you saw 10,000 patients and you found one with the disease and you named it after yourself, right? Those are over. We need all this big data put together to find the patterns in the data that are the keys to solving a lot of our health challenges right now.
And interestingly, as we head towards more genomic and genetic based medicine, where we are coupling genes with certain diseases or the aspect that you may be susceptible to a certain disease, it's going to become more and more interesting and useful, I think, as we get that granular data to be ready to go.
I'm super excited about the potential for AI in understanding genomic data, right? I think there's some obvious dangers there, but I think that's going to unlock a whole bunch of stuff that we don't currently have visibility into.
So tell me, is there anything we haven't talked about that you think is a burning issue with this particular generative AI?
I think one thing that I don't think is well understood right now is the importance of terminology, right? And I think using ontologies like medicine to code the data is so important. That function, right? Because you know how inconsistent humans are. On my first CTKB of the day, I'll call it a kidney stone, and my next one, I'll call it a renal calculus. And I'm just human for doing that, right? But when you use an ontology, those are the same concept, right? But to a generative AI model, they might not be, right? And so that's where I think a lot of people sort of who aren't necessarily like, ontology nerds, for lack of a better term, you don't understand the power of these ontologies and knowledge engines like medicine for being able to reliably and consistently extract information from medical charts. It's a foundational technology, no less important than transformer models.
So these large health systems that we talked about a little bit that are exploring all kinds of things right now regarding this particular large language model and chat model, where do you think they should be focused on their efforts as far as it pertains to healthcare, clinicians interfacing, clinician workload?
Well, I think the healthcare organizations themselves need to put pressure on the vendors to say, look, you've been selling us the same thing for 40 years. Please come up with something better, right? This is very expensive software we purchased from you. And, you and I have had the same experience, Jay, in using large software platforms in healthcare IT. And to do one simple thing, it might be 14 clicks, right? We need, as humans, we are putting obstacles in front of ourselves to helping our patients. These systems are essential, but they need to be better, right? So I think I would love for our healthcare organizations to put pressure on the vendors to be like, use this stuff now, make it better however you can, because every time you implement a new use case, whether it's just being able to do a better search of a patient's chart, or whether it's to do a summarization of a patient's chart, or whatever it is, stuff that we can both help with today. Certainly a lot of stuff like the amazing, Quip UI you guys that we built to be able to take free text and put it into structured form. All of that saves people time, right? And time is the most important thing in life, right?
Time and effort.
Yeah.
Because sometimes the effort takes a lot of time, but it's the effort that really starts to get you burned out over time using it that way. Absolutely.
Yeah. Physician burnout is peaking right now, and who knows how bad it's going to get.
A potential client told me they wanted to create something that would be delightful for a clinician to use. And wouldn't that be refreshing if that would actually happen?
I love that word, delightful. I would love to have a system at work that created delight, right? That would be very cool. I would skip my way into the hospital.
So, Tim, I asked this question of all my guests. If you had a magic wand and you could wave it as far as healthcare IT and medicine, and correct something, what would that something be?
That's one of those wonderful questions, and I'm trying to buy myself time by complimenting you on what a good question it is. I think if I could fix one thing in the healthcare system today, just one very narrow area, it would be for healthcare IT systems to use NLP technologies like ours to do automated patient history summarization. I think that is a very pressing problem where patients come in to see the doctor and the doctor doesn't know them because they've never seen them before. And if they just had a nicely presented user interface view of that patient's, medications and historical diagnoses and procedures, that they could go, "Oh, Mrs. Smith, it's nice to meet you. Do you mind if I spend 1 minute reviewing your chart?" And they can look at it. I think that would help further human-human connection. It would help improve the quality of care. Patients wouldn't feel as disconnected by the doctor and being like, "Oh, I've never had my gallbladder out." This sort of thing. I think, while it's a very narrow area, I think that would be one thing I would like to see solved. I think that would improve performance. And you might say, "Oh, we've got problem lists today, Tim." Well, problem lists are human curated, and it's not uncommon to see, okay, you've got diabetes and heart disease on your problem list, and then someone comes in and they're in a wheelchair because they're a double amputee, and you're like, "Well, I wouldn't have guessed that from reading your problem list," right? So I think that's my one wish, Jay.
What a great answer, and boy, would that be helpful. Well, Tim, thank you very much for being on the podcast again. I do appreciate it. I think our listeners do too. If they want to get a hold of you to talk more about what you do with Intelligent or talk about this topic, how would they get a hold of you?
And they can visit us at www.intelligent.com. We've got an info form on the website. We're easy to get in touch with. So yeah, always happy to chat with anyone. And it's been great chatting with you as well, Jay. Thank you for your time.
Thank you for being on our podcast. That's all for today. Thanks for listening to Tell Me Where It Hurts. Tune in to Healthcare Now Radio and Podcast Network each month for the latest episode. To learn more about Medicomp systems, visit our website at www.medicomp.com. You can also follow us on Twitter at MedicompSys or myself at MedicompDoc, or check out the show notes for links. See you next time.